Oh, thank you, Jan, for this introduction. My name is Mickaël Beaufils. I will share all of my screen so it will be more comfortable for you. Here it should be a full screen now. So my name is Mickaël Beaufils, and I'm with Cécile Guern, and together we will provide you what we expect to be an overview of what is urban geoscience at BRGM. So for the people that may not know who we are, so we are the French Geological Survey. It's about more than 1,000 people. Most of them are in Orléans or at home for the COVID-19. And as you can see, we address multiple domains as they are listed on the left, managing a lot of associated data and having several missions. So scientific research, of course, support to public policy development, very important for the urban geoscience or urban geology topic. International cooperation, mine safety, and training. So basically what most geological surveys already address. So when it comes to speaking about what is urban geoscience at BRGM, so we prefer the term geoscience because it's not only geology for us. So we wanted to give you the flavors of urban geoscience we have. Urban planning, geohazards, geothermy, water resources management, hydrology for urban planning, soil pollution, soil resources excavation, and also it address question of technologies. So we wanted to give you some taste of all of those flavors, and it's not an exhaustive presentation, but we try our best to give you an overview of what we do. Just a small map, a tour de France of urban geoscience. So it's a focus on metropolitan France. Of course, it's about cooperation with the main cities in France. So you can see it's not exhaustive. It's some projects we identify on all the topics we address. So yeah, urban planning topics with some big cities and water resources management. It depends, of course, of where the city is and what are their concerns. So we will provide you some zoom on some of the projects we wanted to highlight. It's not yeah, just to say that we don't master every topics we are speaking about, so we do our best to give you a good taste of it, but we can also forward your question to our experts about this. So one main topic, it's about concerning urban geoscience, it's urban planning. And as you may know, we have a big project in the Paris, so it's called the Grand Paris Express. France and especially Paris is supposed to host the Olympic Games in 2024. So we have a big project of underground infrastructure, extending the subway lines. And we have a project in BRGM in cooperation with the Société du Grand Paris about defining what is the characterization of geology, hydrogeology, and also the geotechnical or geomechanical properties of the place where the subways will be. So very big underground projects. And of course, it's important to, it's deeply linked to urban geoscience. So now I will give hand to Cécile that will present other topics we address.
So do you hear me well?
Yes, we hear you.
Okay, thanks. So we also have projects on quite lots of projects dealing with geothermal energy. So to contribute to the energy mix in the biggest French cities like Paris, Bordeaux, Orléans. So there have been some work to assess the underground contribution to reduce the energy flow at city scale. So there has been a postdoctoral study, but there are also more local studies. So the objectives was to develop a conceptual models of energy systems developed numerical models of underground heat transfers, and integrated to cross-domain modeling of the urban underground. So an example of assessment of the heating demand coverage at city scale through geothermal heat pump with borehole heat exchangers is produced. And the figure shows the heating demand coverage for each municipality of a community. And at the moment, such development are applied to some cities to produce maps of heating demand coverage at city scale. So this is another subject deals with hydrogeology for urban planning. And this is the example of the city of Rennes, where intrinsic infiltration capacity was mapped through a multi-criteria analysis using natural criteria like thickness of non-saturated zone, soil permeability known on the rural part only, the potential presence of clay, the indices of development and persistence of water networks, soil hydromorphy, slopes, under-lake zones. And this knowledge map has been translated into legal map. And as you can see, there is an obligatory infiltration on more than 66% of the territory. And of course, additional local studies are needed when the works are done later on. So that's it for hydrogeology. So still dealing with water, water resource management is also done in Lille and included in urban planning. And in this frame, there is long-standing partnership on water resourcing with the city of Lille. There has been scientific studies to better understand the behavior, quality and quantity of groundwater. Tools have been developed using hydrogeological models to manage the groundwater resource and the catchment for drinking water supply. So it takes into account, so it's very knowledge and management orientated. And at the moment, there is a new project, URBO, dedicated for urban planning, and it has an ambitious goal. It's to construct, model, and evaluate land use scenarios, allowing the sustainability of groundwater catchment for drinking water supply. So actually in Lille, there are water supplies in the north and the south of the city, and it has been a very, it's very dense city, so with lots of impacts. And so the metropolitan area is very, it's the largest in France. And so the urban planning documents cover an area of more than almost 650 square kilometers. And the population is more than 1 million of inhabitants. So we have quite lots of subjects dealing with water. In this case, it's the case in La Rochelle dealing with contaminated groundwater. And there were technical and scientific studies to optimize groundwater treatment. So this is a context of a polluted site, a former railway station of 30 hectares, which is close to the historical city's downtown. And it's impacted by different pollutions, including hydrocarbon, low non-aqueous phase liquid that reach the groundwater. And a redevelopment project is planned on this site. So to densify the site, densify the urbanization. And actually, the geological context is quite complex with highly fractured limestone, and the behavior of the pollutant is complex. So there has been geophysics investigation to evaluate the pollution plume extension and different pumping tests at different scale and timeline, coupled with geophysics to optimize, to evaluate the best option for groundwater treatment. And the treatment is going to take place next year. It's going to be pumping and treatment on the areas, I don't know, to the most purple areas shown on the geophysical survey zone. So dealing with urban geosciences, there are also lots of subjects dealing with geohazards. Like here, it's an illustration of coastal risk in the Basque country, southwest of France. And the objective was to have a better assessment of the potential impact of groundwater on landslides in this urban area. So the monitoring occurs since 2007, and it deals with, it consists in a network of piezometers dedicated to water resurgence prevention. And so to the right, you have some maps locating the network, and to the right, there's the bottom description of one piezometer. So we also, so you've seen in several present subjects the use of geophysics, and actually we're developing some urban geophysics tools. So for instance, dealing with shallow depth imaging. And so we developed no contact geophysical tools for continuous survey, like capacitive coupled resistivity, named OpenMapper, with the corresponding figure to the left, as you could see in La Rochelle. You also have NASW with no grounded geophones, gimbals, with an examples to the at the bottom. So that's seismic geophones that we just drive on the road. So that's a seismic geophone. We also developed urban deep geophysical imaging, and trying to, so this is in development, to use seismic interferometry using urban noise. So this allows the acquisition using urban noise as seismic source, allows to provide signal processing. And so we aim to develop a permanent monitoring network using fiber optics, and also to develop processing algorithms using artificial intelligence for automatic interpretation.
So now coming back to me, a topic I'm more comfortable with. We are, in terms of technology, also working on the building information modeling topic. And we have a special involvement in geotechnics, and to define some standards for geotechnics at the BIM era. So you may know that there are existing standards for geotechnics in all the different countries, but when it comes to speaking about the BIM era and the possibility to connect to 3D modeling, 3D geomodeling, some work has to be done in order to make those standards enter the 21st century. And we have a creative project in France. It's called Mine, you may already know. And this work is going international. So cooperation between engineering companies, research organizations, infrastructure owners and constructors in order to have this kind of geotechnical standards. Our objective is indeed to define what are the main components of the subsoil or subsurface when it comes to describe geotechnical properties. So we have some action to define the vocabularies and to expose them through web semantics principle, APIs to access the data, and what we work on is to be able to navigate into the data. So you can see it on the bottom right of the figure. It's a way to access the geotechnical information from your BIM software. And this would enable you to have access to, of course, the characteristic of the subsurface and to see how they're related. So what we expect to do is to show you how we come from interpretation to go back to the samples or borehole data that were collected. So you can figure how the model has been built, and it will greatly help to the update of this model. So this is how we do it, and we try to reach the international standardization step with the Open Geospatial Consortium, and we also have a collaboration with Building Smart International for this. So here we go to the perspective and conclusion. This was an overview of Urban Geoscience at BRGM. So of course we didn't speak about everything we are working on, but a lot of action, a lot of topic, and a lot of people involved on it. As you may have seen it, we have some active collaboration with the city stakeholders. We have some scientific innovation and technological innovation we propose, something we develop in order to fulfill the requirements of those cities. So it helps us to go from thematic to integrated approach, but it's also about managing the data from their collection to the valorization, including modeling. So in those domains, of course, we must speak about 3D geomodeling. So it's this is a hot topic, how to combine geotechnical data or geological data with BIM on subsurface. We work also on geomodeling, of course, having our own tools that we maintain or extend. When you speak about urban geoscience, of course, it's about interoperability between all those domains of those topics in order to once again fill the requirements of the cities. So this is also why we have active participation in geoscience standards development through a different canal. And of course, these are opportunities of collaboration with other countries and cities, because this also experience and standards of technology we can share together. So thank you for your attention. If you have a question, we will be able to answer you through mails or something like that. Thank you again.